Okay, this is the part 2 of this video, where we shall be using scale drawing to find the direction and the resultant of the boat in the river. These are the materials we will be needing for this class: a protractor and a ruler. A ruler will just use to draw straight line and take length, while the protractor is used to measure the protractor is used to measure the angles. So what we are going to do now, recall that the current of the river is 3 km/h. So we are going to take appropriate scales. That is to say, I'm going to represent 1 cm is going to represent 1 km/h. So it means that on my ruler I'm going to draw 3 centimeters to represent 3 km/h. So I can just adjust this to this point. So here I have 3 centimeters. So I'll take my ruler, my pen, and draw a straight line moving from east to west. Now you know that the river is flowing from west to east. That is the current of the river. It goes from west. So what I'm going to do, I'm going to draw a straight line in the opposite direction to the direction of the flow of the river. So I'll draw this way. So it's going to be in opposite direction. So I will do this. On doing this, so let me indicate the direction. So this shows that I have reversed the direction of the stream. So the next thing I'm going to do is to draw a straight line here from the tail of this vector to represent where it's supposed to head to. You know that he's supposed to head this, is going this way directly, but he has to tilt his boat this way so that he will be able to come this way. So what am I going to do at the tip of this? I'm going to draw a straight line downward, meaning that will give us the resultant of the vector. Okay, this is not straight enough, so I have to draw it a straight line. Still not straight enough, so I have this. Let me see. Okay, and adjust this. So I have my straight line, which is the direction the boat intends to go, which is directly above him if he's starting from a point. Now the speed of the boat is 10 km/h. So I'm going to take my ruler and bring it to this place it upon this place here, then I'll turn it. Then I have to get 15 centimeters from this. Remember that the scale that we are using is 1 centimeter to represent 1 km/h. To represent 1 km/h. So what I'm going to do is to get 15 centimeters from this. So I can still adjust this to get 15 centimeters from this. So this is 15 centimeters. So I have to draw a line across this from this point here down to this place. That is 15. That gives us 15 centimeter. You can draw it to any length, it doesn't matter, as long as it touches this other point. Okay, you want it to touch this point and touch this other point here. So the next thing we have to do is to find this angle here. So this is the angle they ask us to look for, this angle here. It has to find this angle here. So by measurement, I'm going to place my protractor there to get my, okay, the length of this line is supposed to be 10 cm, not 15 cm, because the speed of the boat is 10 km per hour. So we are going to draw 10 cm from this. So what we need to do is just to place my ruler on this point again, then I'll adjust to 10 centimeter. So this is my 10 cm. So all I need to do is to draw a line. It doesn't matter where the line starts from and where it ends, as long as it crosses this point here and also touches this point here. So I'm going to draw my line. I'm going to draw my line through this. So this is 10 km per hour, and this is 2 km per hour. So we are asked to look for this angle here. So this is the angle that we are looking for, this angle here. So to determine that angle, I have to take my protractor down to this point where this line and this one intersect. So I'll adjust this with it, and then I'll also adjust this and move it to this. So by my measurement, my angle is 70 degrees, which is almost equal to the one that we have before. So the angle is equal to 70 degrees. So you see that from measurement the angle is 70 degrees, and we can also get the length of the resultant velocity. That is this line here. So the resultant velocity, we can take our ruler and take our measurement here. So let me bring my ruler close to this. I'll have to rotate this. So by taking the measurement of this line here, my measurement is 9.8 cm, which corresponds to 9.8 km per hour. So my resultant is equal to 9.8 km per hour. So by scale drawing, this is what we have, which is similar to what we have in our previous lesson using calculation method. Now to find the time taken, all you need to do is to apply the formula velocity equals displacement over time. Then we can move on to the fourth part, which is how far from his destination he would land if he ignorantly steers northward. So what we are going to do is to draw a diagram. Having the man steering north directly. So what I'm going to do is this. Let me just erase all of this. Now if the man stares up directly upward like this, let me draw a straight line pointing upward. Okay, so I can get a better line. So this is my line pointing upward. Now what we are going to get from this is that the speed of the man is 10 kilometers per hour. So on this, using our usual scale, I'm going to get 10 centimeters from this, and the speed of the stream, or the current of the stream, is 3 kilometers per hour. So what that means is that if this man stares upward from this, let's say from a point like this, north, directly north, because the current flows from west to east in this direction, the man is going to end up somewhere around this way, because the speed is going to of the river is going to the current of the river is going to push him in the easternward direction, in this direction. So what we are going to do is to measure 10 cm on this line. Let's see if I can get 10 cm from this line. So from the bottom of the line, so I have this, I have 10 cm. So this is my point here, so we're going to be making use of this. So on this, I'm going to draw another straight line that goes this way. Okay, I'm going to draw a straight line across this from here, representing the velocity of the boat. Okay, let me take a note of this. So all we need to do is to draw a line from here pointing in this direction. Then we'll have to measure the length of that line, and then I have to adjust that line towards this point. So I need to adjust this to this point. As long as they touch, it doesn't matter the length. So this is 10 cm. Okay, so this is where it is. This is the length of this is 10 cm. So we have to get 3 cm from this. So I have to take my ruler, move it this way, so I have to move my ruler this way and get 3 cm from this. So I have to push this way on top of this, then I move this way to get 3 cm. So this is 3 cm. So it means that, just this a bit. So this is 3.1 cm now. So I have to adjust this back a bit. 3 cm. So I have 3 cm here. So let me indicate this by drawing a line here to indicate this is where my 3 cm is. Remember, the line is of no importance, but I need to draw that so that I can get the point where I have to draw this up to. So from here, okay, so this dot here indicates that I have to draw my line up to this point. So I have to draw a line from this, a line with an arrowhead from this point to touch this, to cut across this line at this point. Okay, need to adjust that to get the exact position. So I have to draw a line through this, from this point down to this. Now what is important is to get the length of that line, so I can adjust this is to get the length of that line. So I have to adjust this to this point, to exactly this point, and that is going to give me exactly okay. So what we intend to look for is how far the object will move from its position. Now remember that all of this represents their velocity. So this diagram is for the velocity. So this side represents 10 km per hour, and this side represents 10 km per hour. So what I have to do is just to measure the angle. So by measuring this angle here, I'm going to have this. Let me adjust this a bit. So I have this. Then I'll adjust this other one this way. So by doing this, my angle is 16 degrees. Now all I need to do, remember that this diagram you have here represents the vector diagram for the velocity. So with the angle 16 degrees, we are going to draw a similar triangle now in terms of what? Displacement. So the length of the string is the width of the string is 5 km. So I'm going to draw a line 5 cm. I can make use of this. I can make use of this diagram. So on this diagram, without adjusting this angle, so I'll just come to this place without adjusting the angle. I'm going to measure 5 centimeter out of this, meaning that I am taking 1 centimeter to be equal to what? 1 kilometer. So I'll just adjust this and get 5 centimeter out of this. So I have to move this down a bit to ensure that this is at the tip here. So I have this, I have this is 5. So what I will do is just to move this of this line, just move it down to this point here and place it on this. Okay, so let me move it down this way, then I'll adjust. So with the help of this ruler, I'll be able to draw a line through this. So the length of this line, this point where this line, this point and this point where this line intersects this angle, gives the displacement. So we can do this and measure from this, place this on this. Okay, so adjust this to this point and adjust this to this point, which is 1.5 kilometer, which is exactly the same with what we had during our calculation. So the displacement is 1.5 kilometer. So you can see that with both methods, with any of the methods, you are going to arrive at the same answers. You can use the scale method. You can also use the calculation method. So by scale drawing, we also have 1 kilometer. So that will be all. Thank you for your time.